everybody. So in today's video, we're going to be talking about task 7.4, which is going to be about perpendicular lines. And we're actually going to go ahead and jump to the second page of the task. So if it says task 7.4 at the top, go ahead and turn the page. And we are going to define perpendicular lines. So in geometry, the word perpendicular means lines that intersect, where the angles that are formed are exactly 90 degrees. So perpendicular means they intersect at exactly right angles. So here's what a picture of perpendicular lines is going to look like. We're going to have a line like this, and we're going to have a line like this. And I'm going to put some points on those lines just so we can talk about them. Now, when two lines intersect at exactly a right angle, we use a special symbol to show that it's exactly 90 degrees. And that symbol looks like a little box drawn in the corner of the angle. Now, as soon as you see that symbol is 90 degrees, we know that not only is that angle 90 degrees, but all four of these angles would have to be 90 degrees, because once you know that they're perpendicular, they must all four angles be 90 degrees. Now, how do we describe that lines are perpendicular? Well, in order to describe that lines are perpendicular, we use the symbol. It looks kind of like a little mini perpendicular line. So here's how we do that. You're going to name the first line, which is AB, and I'm going to draw my little line symbol on the top. You could also have called that BA. Then the symbol for perpendicular, so you don't have to write out that super long word all the time, looks like a little upside down T. And the reason that that's the symbol is it's like a little perpendicular set of lines. And then the other line that we're talking about here is CD, and that's going to have arrows on both sides to show that it is a line. Again, the most common mistake here is that students forget to use the symbols for lines or for perpendicular. And so be really careful, because part of our language in geometry is the symbols that we use. All right, here are a couple examples of problems that we can do now that we understand what perpendicular lines are. So suppose that line AC, so this line right here, is perpendicular, that's the symbol for perpendicular, to line BE. So I'm going to go ahead and highlight that line. Find the measure of angle DFC. So what I'm looking for here is angle DFC. I'm going to find that so I can kind of highlight what I'm trying to find, which is this right here. Trying to find this angle. Now, before we can find that angle, we need to think about what it means to be perpendicular. So as I said before, when you're perpendicular, you have right angles. So that means that this angle is 90 degrees. That means that this angle is 90 degrees. It means that this angle is 90 degrees. And it means that this big angle here is 90 degrees. Sorry, I had to draw that a little larger because I wanted to get past that 40-degree symbol. What that means is that if this smaller piece of that 90-degree angle, if you kind of ignore this part of the picture, if this piece is 40 and the whole thing is 90, we can find the green angle by using angle addition or subtraction. In this case, the measure of angle DFC would be equal to the measure of that entire 90-degree angle. So the measure of angle EFC minus, take away that other small angle. The measure of angle, this guy right here, the measure of angle EFD. Now we know that EFC is 90 degrees, and if we take away the angle measure we know, which is 40 degrees, we're going to find out that the angle we wanted to know is actually 50 degrees. Now, another follow-up question that we can do now that we know about perpendicular lines is that if we know that line AC, so this guy right here, is perpendicular to line BE, so this guy right here, And then we want to find the measure of angle AFD. So we want to know this whole thing, all the way from here to here. Well, because our lines are perpendicular, I know that this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees. Now, it looks like this green angle is made up of this little 40-degree angle that we've got right here, plus the 90-degree angle that we've got over here. So I can use angle addition to figure that out. So the measure of angle AFD would be equal to the measure of angle AFE plus, because now we're going past that, we're adding in the measure of angle EFD. So that means that this is going to be 90 degrees plus that extra 40 degrees past that, which means all together, I'm going to get 130 degrees when I add those up. Okay, if we go to the next page, let's do one more example. And the reason we're going to do one more example is that this example is a little bit more complex. It's got a lot of stuff going on, and it's going to really involve paying attention to details. So let's say we have all this given information. Let's make sure we mark it on our picture. First, we know that AX is equal to 6. So AX is right here. That length, because there's no sort of symbol over the top, it's talking about the length, is equal to 6. We also know here that AX is congruent to AW. So that tells me that the length of this segment is the same as the length of this segment. You'll notice that I'm adding markings to my picture as I go to make sure that I can visualize what I'm doing, since so much of what we're doing here is very visual. I also know that WY is 13. Now WY goes all the way from here to here. So WY is 13. And I know that the measure of angle AXZ is 32 degrees. Now AXZ is right here. And I know that that's going to be 32 degrees. Finally, I know that the measure of angle YAW is 58 degrees. So, YAU. So YAU is going to be 58 degrees. All right, using all of that information, I'm going to go ahead and try to answer these questions. So first, I want to know what is the length of AW. Now, AW, here's what I know. AW is over here. And I've got some tick marks on there that show that it's the same size as this guy. So if this guy is 6, then this guy is 6. What is the length of AY? Well, AY is this little piece. I know that the whole thing is 13, and I know this guy is 6. So I can say that AY will have to be equal to that whole thing WY minus the part that I already know, which is AW. So that means I'm going to do 13 minus 6, which is going to give me 7. Next, I want to know what is the measure of angle XAY. So XAY is this whole thing. XAY is made up of two smaller angles, this guy and this guy. Now this guy's 90 degrees and this guy's 32, so I think I can figure this out by just adding that up. So I'm going to do that 90 degrees, which just in case it didn't stand out to you, this is that 90 degrees right here, is 90 degrees plus this 32 degrees, which means I'm going to get 122 degrees for that whole angle. And what is the measure of angle XAU? So XAU goes straight across. If an angle makes a straight line, that's going to be 180 degrees. Now I can confirm that by adding together some of these other angles. So if I add it up, 32 plus 90 plus 58, I'm going to get 180 degrees. All right, that is it for today. Thank you guys so much for watching, and I'll see you soon.